Okay, hello and welcome to the Engineering Revision Guide. This is to prepare you for your mock, which is of course next week. First of all, what you're going to need: a pen, pencil, and a ruler as a bare minimum. You also might want to bring along a sharpener and an eraser. And of course, for this little task, you need your revision book. So let's talk about what is going to come up in the mock and how you can prepare yourself for it. So here we go. Now, a good idea to throughout your mock is to highlight any keywords that you're going to need to make sure that you know and don't miss. So that's what we're going to do first of all. So let's zoom into the paper so you can see it. There we go. A customer wants to place an order for 40. That might be interesting later on. Tool carry holders, so that's this thing here. Okay, a technician at your company designs and makes a carry holder shown as a possible solution. The holder is made from stainless steel, which is supplied as a flat sheet and is 1.5 millimeters thick. Okay, well that might be relevant later on. Let's have a look. And there's a picture of it and an engineering drawing. Third angle projection. There's some detail here which might be relevant. There's some measurements. And then here, to make the handle, the technician used a CAD package to draw the shape, a plasma cutter to cut the shape, deburred the edges, bent the hook into position using an engineer's vise. Okay, right, so that's the setup. Let's have a look at the next page then, because we haven't actually got to a question yet. This revision book, of course, is written in exactly the same way as your mock will be written in. Now, here's the actual question. And it starts like this. Zoom in again. Okay, explain the issues with the design of the tool holder. So that's your first command word, the word explain. Think about how the tool holder is made and how it will be used. You should consider dimensions, okay, tolerances, okay, physical form, attributes, materials, and processes. Write your answer in the line space provided on the next page. That must be over here. There it is. You may annotate the diagram to identify the issues. So we are allowed to write some notes around this diagram. So let's zoom out a little bit again and let's get on with that. So here it is. It's a tool holder of some kind. We know it's 1.5 millimeters thick and we know it's stainless steel. Apart from that, we can look from the page behind, a bit more detail. We also know it's got some aluminium pop rivets. Okay, we know from our year 10 projects that the aluminium pop rivet is not particularly strong, so that might be something we need to improve. So here we go then, let's start annotating. Now, although you're not getting marked on neatness, it's always a good idea to keep your work neat. So let's try and get these as neat as possible. The first feature I'm going to point out is the corners. So sharp edges. Might be a hazard. What else? Now, considering this is a handle and you've got to grip that with your hand, that might be another issue. So perhaps we'll highlight that. I'm going to keep all my arrows in the same style, some kind of curve. So what is the issue with this handle? Let's zoom in a little bit more. Well, it looks to me that that would create quite a pinch point, and it's not particularly the right size for a hand, especially my hand. So handle is too small. The material is too thin, so I'm going to add that onto it. And this edge here, so I'll do another line down here, and I'm going to say this may create a pinch point. Okay, so remember at this stage you're annotating this design ready to write it in full sentences here. This is where you're going to get your marks. Okay, so let's go back to here. Now the overall design, is there any design flaws? Let's have another look at it, keep going with it. It looks to me that there's a misalignment here that could catch if you're carrying it around. That's create a potential hazard. So I keep going with these slightly curved arrows. Okay. Sharp edge hazard. So I can talk about that in the next bit. The holes, we know it's a tool holder, and the holes are identical. So in terms of your tools that you would carry, you know, screwdrivers, pliers, scribes, punches, for example, etc., etc., all the classic engineering tools, they're all the same size. So potentially that could be a design improvement that could be made. Same sized holes, question mark, something just to prompt you in answering your questions next. Here we go. Now, these two are pop rivets, okay? We know that from the previous page. Just check back, keep checking back at your previous page, and the mock will do the same thing. So you'll just check back on this page just to get the detail. Let's zoom into that. Now we know that there are aluminium pot rivets. Pot riveting is perfectly fine for many applications, but potentially when it's a lot of strain on there, it won't be mechanically strong. And they're also very close together. Okay, these could be very easily moved to the edge, or an additional two perhaps. You'll have to do that. You have to work out what you're going to say yourself. So let's zoom out. So I'm just going to make some notes ready for the next page. So additional pop rivets needed question mark. So I can talk about that. Although if you look at the bigger picture, I suppose, when you think about the whole thing, actually if this is one sheet of stainless steel and this is one sheet of stainless steel, is it necessary to have, if it's going to be bent anyway, why is it necessary to join two pieces? Wouldn't it be easier to bend one piece and have it one continuous motion, one continuous piece? So could it be one piece? Question mark. So there's lots of things going on there that I can write about, and that will prompt you to write in a really succinct and efficient and better way for your actual main writing. This is where you're going to get your marks from. Okay, so now I've got my points on this page. Now I can write my answers here. Okay, so let's start writing in some of these answers then. I think I'm going to start at the top and move my way down. There's no right and wrong way to answer it, as long as you get it all down there and you write in full sentences, then you'll be absolutely fine. So let's zoom in and show how you could write this in full sentences. So I'm going to start with the handle and the shape of the handle being an issue. Move my chair along so I can get there. So first of all, I would say the handle shape does not allow for large hands. It's too sharp at the edges and may have a trap point, which is that point there. Also, the square edges create a hazard. That's those bits. Let's move down to this area here, the sharp edges where the two pieces are aligned. So the the two sections are not the same width, and this has created a sharp edge. That's that bit there. Moving around. So all the holes are the same size, and this does not allow for a range of tools. So that's these bits over here. So now let's talk about the shape having only two in the middle and the potential for it to rock. So we can put that into a full sentence. So I've put here, there are only two pot rivets to join the two pieces together, and they are positioned too close together. This does not give the best mechanical strength. Okay, and on the principle of mechanical strength, we know that pot rivets are not the most mechanically strong either. But you would notice that what I'm doing here is I'm writing about the issues of this design. What I'm not mentioning is how to improve it, and I think it's a good time to mention that now. Is that you must read the question properly, and it does say here. If I zoom in back again, it says explain the issues with the tool design. That's the question. It does not say list all the solutions. That comes next. Okay, when we turn it over, it does say here, you have been asked to consider different ways to manufacture this carry holder. You should consider different designs and processes to make it. Sketch an idea of the carry holder, etc., etc. So there we go. That there tells you that actually you will be designing a better version, but that is not yet. When you're on this page, you stick to the same design. Now, it doesn't mean you have to do it in order. It doesn't mean you can't swap and change. It doesn't mean you can't think of the next question, but you need to make sure you're writing the right answers in the right places. Okay, so I just go back to this point of mechanical strength. Pot rivets, we know, are not massively strong. They have a low tensile strength. The resistance to be pulled apart is low, so probably should be upgraded with something like a high tensile bolt with a larger cross-sectional area, which will mean it'll be a far more suitable mechanical fixing. Okay, so I'm going to put that here as well. So I put here, the choice of a pot rivet does not give the best mechanical strength, and is also non-removable. So if this part was damaged in any way, maybe there's a chip, maybe there's a bend, some kind of damage that needs to be replaced, this part cannot be replaced because pot rivets are not removable. You have to drill a pot rivet out, and a nut and bolt, of course, you can undo. So that might be a potential improvement factor you can use. Now, it's also worth thinking about the design as a whole. We haven't really mentioned the material yet. The fact is it's stainless steel. We know that from the first previous page. We know it's stainless steel, but we also know, let's go back here, we've highlighted a few things, haven't we? We've highlighted the fact that it's stainless steel and is 1.5 millimeters thick. Now, if you think about how thick 1.5 millimeters is on your ruler, is that going to focus? There we go. It's very, very small. So trying to carry something which is that thin, probably about the same thickness as a piece of cardboard, then that's clearly going to be quite a sharp thing to put your hands around. That's another thing you might want to talk about improvements. So the final point I'm going to make on here is, and would create, so the material choice is too thin and would create discomfort. You can imagine, can't you, if you were carrying something in your hands and it was just pushing against there, then that is going to be particularly uncomfortable. You want to have something a lot thicker. Okay, so that's the first section kind of wrapped up. There's lots of information in there, lots of points. Now Now, always at this point, you want to make sure that once you've answered it, you want to go back through the question and make sure that you have answered it as fully as possible. So double check that question, see if there's anything you can get extra points for. So it says, think about how the tool holder is made. We haven't really talked about that yet. You should consider dimensions, tolerances, physical form, attributes, materials and processes. Well, we've talked about materials, that's done. We've talked about physical form. We've talked about dimensions. We haven't really talked about processes. So let's have a little think about that. If we go back a page. There we go. And we zoom back in again. It tells you some information here, doesn't it? To make the handle, the technician used a CAD package to draw the shape. Okay, that's probably a very good thing to do. It's all been done here, no problem. Plasma cut to shape. So plasma cut is a process of cutting out, it's a bit like a laser, and it will cut out. That's also a very good tool to use. You wouldn't really get any problems with that. Deburring the edges, that just means literally to file down. Okay, and then finally it says bent the hook into position using an engineer's vise. Now, everyone knows what an engineer's vise is. We have them in school. So you can imagine trying to bend a piece of stainless steel with that. Would that produce accurate results every time? If we think, remember, you're making 40 of these, would that be sufficient? Just bending it in an engineer's vise. So the examiner here is really testing you on your ability to understand engineering and to understand the process that you're being asked to do. Okay, so when it comes to that, you want to talk about this bend here being done with an engineer's vise, and you can simply say that, okay, so it says there, the bend created using an engineer's vise may be inaccurate. That's one word. Okay, so that's considering all parts of this process and the materials and the physical form. We've got everything in there. That's the sort of level of detail you are going to need to go into in this section. Okay, so the next section is the improvement section. We'll just zoom into that. Okay, so you have been asked to consider different ways to manufacture this carry holder. You should consider different designs and processes to make it. Sketch a design idea for the carry holder that is an improvement to the existing design proposal. You may annotate to indicate design improvements. Okay, so we know from the previous section all the things that have gone bad, all the issues. We now need to design something which addresses these issues. In other words, solutions. So first of all, I'm going to sketch something out and I'll talk through the suggestions that we can do. Obviously, there are many different ways of doing improvements, so I'll just suggest a couple. So here we go. Okay then, so what I've done there is I've done a sketch that has some improvements. So the first thing I've done is I've kept the handle nice and rounded. So there's a rounded edge here. I've actually put a new material in there, so I'm going to choose a polymer, so a type of plastic. Polymer handle. You don't have to necessarily name the plastic, but if you just say it's actually going to be a polymer, that therefore is going to be a nice and easily shaped section around there. It's now one piece rather than having to join two pieces together and have some pop rivets. Instead, what we've done is we've just done the whole thing in one piece, so it's one simple bend across there. And I've done a range of different holes as well. So I'll just label those quickly. Range of tool holes. One bend, no joint. Okay, so there's a number of things there that I've done quite simply to improve the design. Okay. The next section is to write those out in full so that you are communicating with with the examiner, exactly what those improvements are and showing your knowledge and skill. My favourite fruit, by the way, is a strawberry. So just to prove that you've actually watched this video, I'll be asking you what my favourite fruit is, and there's the answer. Stay tuned though, because I might change my mind. So, justify why your design idea is an improvement. So let's zoom into that section to show you. Question: justify why your design area is an improvement on the carry holder. Explain which processes you would use to make your idea. Okay, so why it's an improvement and what the processes are. So that's really important that you answer that when you do this. Okay, so for example, first one, simple one, by designing smooth edges so there's no injuries can occur. Okay, the next thing I've said is the handle now has a wider, more ergonomic design made from polymer, such as, and I've listed one there, HDPE. A really nice thing to do is just have a few materials up your sleeve ready to answer questions like this. Plastic's an easy one because the plastic that does all things is HDPE. It stands for high density polyethylene. It is the plastic, the same material as the stools you sit on in schools. It sits on the steel frame. The actual seat part of it is for HDPE. As is your wheelie bins at home, garden furniture, and dustpans. Lots and lots of things are made from this material. Buckets, all sorts of things. The material itself, the plastic that HDPE is, can be processed in so many different ways. So if you ever get a question on plastics, then the answer invariably can be at least HDPE. Okay, so that's what I've put down there. So that's that part here. So you can say how that would be made. And you might want to, so that could be injection molded. Which is a good way of creating that part. If it was done by a technician in school, chances are you wouldn't have a injection molder, although you can get small bench mounted ones. So you'd probably be more likely to have layers of the HDPE and then just file it round into shape. Okay, so you can put that there. Okay, so I've just put injection molded or cut from sheet material and filed into shape using a hand file. And then of course the devil's in the detail. So how would it be joined? Well, you've got a number of options. There are some really strong adhesives. Adhesives are a posh word for glue, so I use that one. You could nut and bolt it, I suppose, but adhesives are better. Okay, so it says joined using a contact adhesive. There we go. So what else then? So what else have I done? Let's zoom out and have a look at my drawing to remind me. I've also got one bend. This is no joint, so I've taken the need for the pop riveting. So I can say about that, I can clarify that when I write about it. Okay, so I've put this design now has one simple 90-degree bend, which means that there is no need to use the pop rivets. You can also go into detail about how handling one part is so much easier than handling two, and the part could be cut out in one go, so which obviously that means that the design is quicker to manufacture as well. So all that detail you can put in there too. What else have I got in this design? So I've also put a range of tool holes which you can write about too. So all that just needs to be put into sentences in detail. I won't make the video too long. I just leave you with that to do. As long as you use technical vocabulary, as long as you write in full sentences, you'll get the mark. Remember again that you're going back to the question. Always go back to the question. So why is this design an improvement? Well, I've started that. And explain which processes you have used to make your design. So I've mentioned some of those, and I will do if I continued. Okay, so it's that level of detail you need for this section. Okay, the final section of this revision guide, okay, is the last page, which talks about tolerances and anomalies. Okay, so let's just talk through that quickly. First section, you're going to have in your the section you're going to have in your exam is about obviously these two things. You'll be shown an engineering process. And we talked about this in school, but ultimately it could be any of the machines that you have around the workshop. So something like the center lathe, it could be a cutting process with a hacksaw or a bench shear. It could be using the milling machine, it could be using the pillar drill, it could be using some joining technique. And ultimately, you have to read the question really well, and then you'll be presented with a set of data. For example, like this. This is saying drilling 2 holes 32 millimeters apart, and then there'll be some data. What you have to do is work out what's going on and what the issues are, and of course it will depend on what the process is. In this case, it's drilling 2 holes. Now, first of all, looking at this, you have to interpret that the fact it says 2 holes at 32 millimeters plus and minus 0.5. And what on earth does that mean? Well, what that means is it means you're allowed 32 point and then plus 0.5 there for the maximum size. And I would recommend doing this in the exam so you're fully aware of it. And then minus 0.5, so 32 minus 0.5, so 31.5 is your minimum. And that's what tolerance means. It means the level at which you would accept, or the level at which you would tolerate your maximum and minimum. Okay, so now for using that information, let's look at this data. So let's zoom in even more. There we go. So 32, that's bang on. 32.0, we're happy with that. That's a tick. So you could even annotate that by saying, yep, that's intolerance. Same with the next one because it's the same number. 32.1, that's within there. We're happy with that one. 32.5, yes, that's still within the maximum limit. And then we get something strange. We get a 21.4. Well, that seems very out of tolerance. First of all, it is out of tolerance. It also seems really unusual. We'll come back to that one. 32.6, that's just out, so that's out. And all the rest of them are too high as well. So now you've had a look at this data, you can start to use your knowledge of engineering and the processes that we've done to start thinking about what on earth must have gone wrong for this situation. Okay, now in the real exam, in your mock, you will have a lot of detail about the setup of this. So drilling 2 holes, how is it set up and what's going on? Why could this have possibly gone so wrongly with the data? So let's have a look at that. Okay, so this is the milling machine. It's used to mill across certain materials. It will go across a material like so. So I'll just turn it off a second. So this could be one of the processes that you're asked about. You could be milling a material across the surface, and you would be asked why and what could possibly be going wrong with this process. So let's have a little look at this machine. So the setup here is that it's got a vise. The vise is done up with a handle. There are bolts either side to keep the machine in alignment, and there is a cutting surface here, a cutting tool that will cut along the surface. There's a number of things that could go wrong with this if you're cutting many of them. These bolts may not be done up tight, the vise itself may not be done up tight, and that would mean that the alignment of this jig, this clamp, would come out of alignment over time, and that would affect your results, of course. If we take a closer look at the tool itself, the tool itself spins around. There's some coolant here to cool the whole thing down. If you don't use that coolant, what happens is this surface here gets really, really hot and it starts to wear. Okay, and when it wears, it starts to get blunt, and of course that will affect the quality of your work and indeed the measurement of your work. So perhaps one of the issues is that it hasn't, the coolant hasn't been used, or maybe the wrong coolant has been used, and therefore your work will be out of alignment. Maybe the bolts, like I said, the bolts could be part of the problem as well. Let's have another think about this machine 1 second. I'm going to move around to this angle, and we're going to have a look inside here. Focus, there we go. So what you've got here, and the reason I'm showing you this is because we've got some of this material here. Now this is waste metal. It's commonly known as swarf, and that could be a factor. So if you're cutting a number of parts, let's get that out of the way as well, and you're clamping your work with this vise, if you left that swarf in there, that debris, that waste material, that dust, then the clamping situation would not be as accurate as it could be. So there's some more there. And you can see that if it doesn't get brushed away with our little brushes, then that could cause an issue. That will cause an inaccuracy in your design. So all those different factors will affect your ability to work accurately, and that is what you've got to talk about in your exam. Well, your mock may not have a milling machine, of course. You may have a number of different machines. You may have the lathe. Tool posts could come loose. You could have waste material in the chuck. You may not be using the right coolant. 2 lathes there. You may be using the bench shears by using a stop and cutting using the bench shears, in which case something could come out of alignment. You could, you may not have the correct safety procedures to actually get things in line. What else do we have? How about the pillar drill? The pillar drill does need, of course, clamps. So maybe your clamps, which would bolt into here, may not be in line, and you could be drilling the wrong speed. As we know, all our drills have different gearboxes, so maybe it's the wrong speed. And of course, over time, the drill bit itself will wear down. It will get smaller as it gets worn away. What else could be done? Maybe you're bending something in the vise, and you were using a hammer to bend over to a 90 degrees, and maybe you haven't done it up tight enough. Maybe there's waste metal within the device jewels, which is affecting the quality of the grip, which means it's slipping. There's a whole host of things that you have to think about and explain and write in full sentences. Okay. I think I've changed my favourite fruit. I think my favourite fruit now would be a kiwi. There we go. So if you've been paying attention, you'll know those my favourite fruit is. Good luck.